All right, so I got Dave Gibson here with BioWorks. Kind of give me the mile high and overview of what you guys do.
Okay, starting with the mile high. A long time ago, 50, 60 years ago, it was recognized that small municipalities are different from the big guys. Small municipalities have their own needs and wants. And among those needs and wants in wastewater treatment is a simple treatment system. It's not terribly difficult to operate, yet gives good results, solid good results. And the concept of extended aeration was recognized as probably the best approach for those smaller municipalities. In our case, that would be, in municipal terms, 150,000 gallons a day through 5 or 10 MGD, maybe, probably 5 MGD. Uh, extended aeration is activated sludge, but with a larger than normal for the big guys aeration basin, which allows for buffering of the influent. You have a lot of time in the aeration basin or the activated sludge basin, so you have a lot of time for things to equalize, and it's easier to operate for the operator. People came up with different ways of approaching that. It was quickly recognized that if you took a normal activated sludge sequence of events, sequence of operation, and you made the aeration basin bigger, bigger, and bigger, very soon you wind up in a situation where you need more energy to mix the basin than you do to treat the influent BOD and ammonia. So you're kind of limited. But people came up with different ways to beat that limitation. One being an oxidation ditch, where the momentum of the water going around in the ditch provides enough mixing. Another being SBRs, where you only aerate and mix a portion of the time. And a third being this kind of setup that we talk about, in which you have a normal activated sludge sequence of events. You got a screen, you have an activated sludge basin, you have a secondary clarifier, and whatever appurtenances you need around it. And in our case, for municipal jobs, the aeration basin normally has a residence time of about 2 days, give or take. Depends on the load. To make that work, works in a way where you can mix it as well as aerate the waste, we use fine bubble diffusers. Fine bubble diffusers are unquestionably the most energy efficient way of getting oxygen to feed the bugs. So we use fine bubble diffusers, but to mix properly, we have them move back and forth. So instead of being fixed in one place where they would mix, say, this much, now they move back and forth. Now they mix that much.
So normally they're just locked in place and they're really just creating one zone, and instead you're trying to sweep kind of around.
Yeah, if you go to almost any large city's wastewater plant, you'll see rows on the bottom of the plant. You'll see rows and rows and rows of normally disc diffusers, thousands of them fixed to the floor. One of the ways to save money with our type of system is to use, instead of a concrete basin, which you need if you're going to fix things to the floor, is to use a lined earthen basin. Most of our systems use lined earthen basins, and that's possible because nothing is fixed to the floor. Our fine bubble diffusers actually are suspended from floating air headers on the surface of the water. The diffusers are suspended below there, down near the floor of the basin, and they move back and forth laterally. The whole header moves back and forth quite a bit. Depends on the size of the basin, what that amount is, but it goes back and forth,
Yeah.
which allows the mixing of the entire basin properly. Properly designed, it works perfectly. You have a classic activated sludge system. You get the same kind of results as you would with anybody else's activated sludge system.
Yeah.
We typically guarantee the results as long as we get to work on the design with the engineer. And normally we guarantee it 10 BOD at 10 milligrams per liter, TSS of 10 or 15, and ammonia. Well, we guarantee 1, but that's ridiculous because with the sludge age in a classic activated sludge system might be 6 or 8 days, and this is more like 20 or 30 days. And the longer the sludge age, the more time you have to nitrify, is the term, to get rid of the ammonia. We have 20 days. The ammonia is gone. It's gone.
So kind of talking about some of the advantages here. So you don't have to, concrete's pretty expensive. So this isn't some big concrete thing. And could you, if this was a colder climate, could you put some sort of like housing over this to like?
I've talked about that, but you don't have to. It is well mixed. It does not freeze. The aeration basin will not freeze. The only thing that might freeze would be your clarifier after the aeration basin. A lot of people put covers over the clarifier to keep that from freezing.
Gotcha.
But there's enough mixing intensity, and air is hot. The air that you blow in there is warm when it comes in there. So you're adding BTUs to the system. It doesn't freeze.
Understood.
I've never seen one freeze. So this is a cutaway of one of our diffuser assemblies. Somebody played with it, sorry.
Who played with it?
Somebody,
Oh,
somebody else came on and played.
All right, so this is one of the assemblies.
This is a cutaway of one of the assemblies. I don't know if you can see that thing down there, but we have racks of diffuser assemblies. There are 4 tubes. This would be over to here someplace. So we have 4 tube diffusers mounted to this one manifold, and about 2 meters away, about 6.5 feet away, there's another one just like this. It's a mirror image, and the tube diffusers just connect between them. Each tube diffuser is supplied with air from above, from up there on the surface, which comes in here, goes through there, and winds up being dumped on the outside of the support pipe. The pipe does nothing from a process standpoint. The air is released to the outside of the pipe, which puts it on the inside of this diffuser membrane. And the diffuser membrane, which is this, ours are silicone, which is a damn good material. And it's punched with thousands and thousands and thousands of little tiny slits that are just barely over 1 millimeter in size, 1 millimeter. So they form little tiny bubbles. And the advantage of little tiny bubbles is really simple.
More surface area?
Yeah, if you took 1 cubic foot of air, for example, 1 cubic foot of air, and you calculated the surface area of that 1 cubic foot of air, that's the amount of surface area that the oxygen has to get out of the bubble into the bugs that are out here in the water. Now break that 1 cubic foot of air up into 1 millimeter bubbles. Now calculate the surface area of all those bubbles.
Yeah.
It's tremendously, hundreds of times bigger than that one was. So you have many, 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 many more times opportunities for that oxygen to get out of there to the bugs. That's why they're so efficient. The reason that we do it this way for this is because it's extended aeration. The circular disc types are really good for those large plants where they have 3 or 4 aeration basins in parallel. The closer you can put them together, the more energy efficient they will become. So if it's well designed, one of those systems is actually more energy efficient than one of these. But one-on-one, this is actually more efficient than that is.
If you look at the whole, it sounds like if you look at the whole system and some of the other things you have to bring in.
Yes, it ain't.
Those,
It's not
close.
Well, it's not even close, and it's not a simple question. Somebody who really understands aeration has to look at it in detail. And I know you're an engineer. Very few engineering firms have people who really understand aeration in detail. We do. Yeah, we suppliers.
Right, you guys are experts.
That's our name. Yeah.
And I'm sure you guys had to spend a lot of time actually training engineers and helping educate them on
We try.
what a good aeration design looks like.
Yeah, our whole philosophy, our company philosophy is that our job is to educate our potential customers so that they'll understand why they should be doing things the way that we think they should be doing them. Because I think what we're offering is the best possible approach for a small town. You take a small town, and you probably are dealing with them where they have lagoons. You probably see that all the time.
All the time, built in the 80s, 70s, 80s.
70s or 80s, right. Now the state comes to them and says, all right, your lagoon, which puts out 30-30 or 25-25 effluent, that won't cut it anymore, pal. Now you got to go to 10, 15, or 5, or whatever it is to get tight. Well, how do you get there? Well, you could put in a classic activated sludge system, and you could do that, but it'll be expensive. One of these systems will cost 20 or 30% less on bid day than a classic activated sludge system because of the less concrete, the small amount of concrete. Our system, number one, costs less on bid day than the alternatives, the concrete alternatives, is easier for the operators to run because you have all that volume in there that buffers the system, makes it really easy, and it's easy as hell to maintain. There's nothing to it, really. It's easier to maintain than the classic system. For example, if you have those little discs on the floor, they're usually 9-inch, they come loose all the time. Mother Nature, Murphy's Law, whatever you want to put it, things happen. Right. Well, how do you work on it? If one pops loose and you have 1,000 of them in your basin, what do?
Just shut it down.
Shut it down, drain the basin, go in and fix it. Well, nobody does that unless they have to. So you wind up wasting air, is what it boils down to.
Just sit, and those are some of the ones you see coming out of the side or something.
Right.
It's
You'll
all
see big boils on top of the water.
seen those.
I'm sure you have. But they're everywhere. Every plant you go to, you'll see them. When it gets bad enough, they'll drain the basin, or they have a maintenance schedule where they shut one basin down every year or whatever to go in and fix them. That's why. With ours, you never have to shut the basin down because there's nothing on the floor. You can retrieve these things from the surface, from a boat. We have a system where each one of these is a rack. It's got 4 diffusers and 2 manifolds. From the shore, if you throw a switch, you can choose which one of these racks you want to address, and it just rises to the surface. It waits for you on the surface to come and get it.
You come grab it.
You come grab it, put it into your boat, and work on it.
Oh, that seems super simple.
As easy as possible, given the situation. A lot easier than draining a million gallons of crap and
figuring out what to do with it.
figuring out what to do with it. Exactly. So maintenance-wise, it's easier. Operationally, it's easier. It costs less to begin with. And energy usage is as low as you can get with this kind of system, because these fine bubble diffusers are the best.
All right. What do you guys have any kind of applications that are pretty interesting you guys currently are working on, or maybe have installed, success stories, kind of
Working on? That's a good question. We have a couple of jobs in Utah up in the mountains. It's in Colorado. That might be of interest that we're working on. They aren't installed yet, but they will be.
what's kind of the custom, what was the need?
The one I'm thinking of is an upscale ski resort. People have tons of money, but they had a lagoon. The state finally told them, you can't do that anymore, folks. You got to upgrade. So they're upgrading, and they're putting in our system. Should be installed next year. It's taking a while. Always takes a while, but it'll be installed next year, and it'll do the job.
So you're seeing a lot of demand in terms of the lagoon, people with existing lagoons. A lot of states are trying to, they are phasing those. They're not trying to.
Amen.
They are phasing those out. And these, one of the solutions is kind of your product coming in and doing that. Okay.
I don't know about Colorado, but a lot of states are requiring denitrification.
Yep.
Do they in Colorado?
The limits are like under 5.
Under 5. Total nitrogen under 5?
Yes.
Okay. Total nitrogen under 5.
Correct. That's
challenge.
It is.
We can design our system to denitrify in the aeration basin. Normally we can get down to 8 or 10 in the aeration basin. If you have to get to 3 or 5, the tougher numbers, then you have to, or you should install a denitrification filter, tertiary filter afterwards to scour that little bit of extra out of it.
You had mentioned costs. I want to pick your brain for a moment here. So I see a lot of MBRs going in to these small communities, and one of the things I worry about is the operators running an MBR. It's a completely different level of system. How does like kind of costs operationally, how do the two kind of compare when you guys?
MBR costs are coming down, to be honest, but I would say that one of our systems, if you from day one on bid day, would be half the cost of an MBR, give or take.
Yeah,
a lot less, not a little less, but a lot less. And from an operational standard, I'm an aeration guy.
you get it.
MBRs operate with a mixed liquor level in the aeration basin of what, 8,000, say, milligrams per liter. Heavy.
It's a
heavy waste. And they have to, because they only have a little bit of time in that basin. That their residence time is two hours or something. So they have to have a real high MLSS level in the aeration basin to make the whole system work properly. These guys don't like that. Nobody's device likes that. Aeration device likes that. There's the thing called alpha, which is basically there's only one way to test aeration devices, and it's a well-defined ASCE technique that's done in clean water. Alpha is basically the relationship of how fast you can transfer oxygen in dirty water related to how well you can do it in clean water. So the lower the alpha number, the more difficult it is to transfer oxygen into the wastewater. With an extended aeration system, from us or anybody else, alpha will normally be in the 0.7 range, 0.6 to 0.7. With an MBR, it's more like 0.4. In other words, you need 50% more oxygen to do the same job.
which is energy cost.
which is energy, which is air, energy.
Right.
So your energy costs will be tremendously higher. Your cost on bid day will be tremendously higher,
Capital costs, operating costs.
and your operational difficulty or complexity is much higher. This is as simple as it gets.
If you were going from a lagoon to one of these, is that going to be like lagoon to MBR or lagoon to one of these systems? Which one for that operator who he might be the only operator for 100 miles from that site?
What's that learning curve like for him?
I would say that if you take an operator who's got a lagoon system and you show them an oxidation ditch or an SBR, or God help them, an MBR, they start getting palpitations, right? It scares the hell out of them because they're not used to it and it looks complex and difficult. You show them this, it looks pretty easy because it looks very similar to what they're used to.
Right.
And it is.
Does.
And
I'm
it
looking
is.
at it, I'm like, man, this is pretty simple.
Yes, it is. It's very simple. Now, in most states, you have to get a higher level operator, grade level, to operate an activated sludge plant than a lagoon. But as long as they're willing to make the effort of moving up a step,
This is easy.
I think that has to happen. Like that has to happen regardless of what they're doing.
oh, if they get an MBR, you got to have the highest possible level normally. Now, ours would be a level below that normally. Depends on the state, but no, below that, and then a lagoon, of course, is below that.
Cool. I've got no more questions. That was great.
Very good.
Thanks for meeting with me today.